Hello everyone, welcome to Uncle. Good evening.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening everyone.
Good evening, sir.
Good evening, sir.
Good evening. So let us discuss today about mean free path. What do we mean by mean free path? Now, we know that gas molecules, they are moving all the time. They are never at rest. Suppose there is a particular molecule. Let me make some of them randomly distributed. Okay. Now, in order to show you the path of one, this red one, it comes and it collides with some other molecule A. And then, of course, it gets deviated from its path. And then again, it collides with another molecule B. And then it goes this way and collides with C and then D, like this. Okay. It may follow any path, any random path. Okay. I have just drawn one of the possible paths. But now you can see between any two collisions, there is some distance along which there is no collision. Between two successive collisions, there is some distance traveled by the molecule during which it does not undergo any collision. Means the molecule is said to be free. Or we can refer this path as a free path. Okay? Because the molecule is not interacting with any other molecule. So we can call it to be free. But the path length, you can see from this diagram also, this path length, it is small as compared to this one. And this one appears to be the smallest one. So these path lengths, they will be different, of course, in general. So that's why we take the mean of all these free paths, and that is referred to as the mean free path. Clear or not?
So can you please repeat?
Complete?
Just I got your point of the there is some distance traveled by the molecule without any collision.
Yes. And this is called free path. But there are various free paths. This free path, this free path, this. And in general, they are different from each other. So in order to give it a meaning, we will go for the mean of this quantity. You will take the mean of all such free paths. And when you take the mean, it will be referred to as mean free path. Because we cannot calculate all these free paths. It is very difficult. We don't have idea about the actual number of collisions that are taking place in a given time in a gas. So that's why we always talk about mean free path. We always estimate. Actually, this is the estimate. Okay. Obviously, there are so many molecules. We cannot get this exact number. Never. And it is denoted by lambda. Suppose this is lambda 1, lambda 2, lambda 3, and so on. So lambda, it is mean free path. And lambda 1, lambda 2, lambda 3, these are free paths. One important announcement, students. Saturday, there will be no class. Okay. And about tomorrow's class, tomorrow there may be a class, but you will get a message on your Telegram app or channel. Okay. Regarding tomorrow's class, that is Friday's class. Saturday class, surely it is not there. Please note up. Okay.
Sir, actually, I want to ask about some material.
1 minute. Please note down. That's why I have written on the slide itself. Okay. Yes, please ask.
Sir, actually, I was going to buy a book for thermodynamics. So which one I should buy? I mean, Humansky or Garg, Bansal and Ghosh? Which one is the best book?
According to me, you should go for Garg, Bansal and Ghosh.
Okay, sir. So actually, I'm also reading some books along with the topics that you are teaching us.
That's very good. But none of the book will be complete. Please keep this thing in mind.
Yes, sir.
And if you want to read it, it's a good thing.
Sir, actually, I want to entertain myself with the concept, with the full concept. I mean, as much as I can do. So that's why I'm getting one by one and reading them with the topics that are.
If you are concerned about the concept, then you need not buy any book. As I will be discussing each and everything in the class, as you have seen in the previous sections also, because we have completed 3 sections. Okay. But if you want to exercise more questions, then of course you can go.
Yes, sir.
Add uncle material, salt, paper. What do you mean, Rita? I'm not able to understand. You are asking salt paper ko kaise solve? What do you mean? I'm not getting your point actually. Am I audible?
Yes.
It's up to you now how you want to practice.
Okay, sir.
It is but the best thing is first try the question paper yourself. Treat it like the unsolved one, like the real exam, and then check your answers. That is the best thing to do. Okay?
Okay.
And please do it in a real time. Do you know what do I mean by real time? Just like the actual exam, with a proper time schedule by setting up the alarm that you have to complete this paper in this specified amount of time. That is the use of that exam, okay, or paper. Clear?
Yes, sir.
Now everyone noted about this Saturday and Friday. Can I read it?
Yes, sir.
Yes, sir.
No. So this is mean free path, and lambda 1, lambda 2, lambda 3, they are the free paths. Now, what is the definition of mean free path? If we have to put it in words, the average length of free paths is referred to as mean free path. It is the average distance traveled by a molecule between two successive collisions. This is the exact definition. Okay? And it is denoted by symbol lambda. Symbol lambda. So I'm not going into the derivation of these, how the expression comes at all. So straight away we will write the expression for the mean free paths. So this expression that we use today, actually it was given by Maxwell. This expression for lambda, it was given by Maxwell, because he was the one who introduced this Maxwell-Boltzmann distribution of molecular velocities, and a rigorous derivation was given by him regarding the gases and their velocities and everything. So exact expression for lambda was given by him, and that is lambda is root 2 pi n d square, 1 by root 2 pi n d square. Okay, root 2 pi n d square. Now let us see the use of this relation. Use of this relation. Here n is the number density. You can note down. Here n is the number density actually. N is the number density. D is actually the diameter. Let me write. Number density of molecules. D is the molecular diameter. Molecular diameter. So this is a question from IIT Jan. 1 mole of an ideal gas Yes.
Have already been done.
Your voice is breaking, Sanju.
Sir, I'm asking how much questions have already been done. I have done it. The website is not working and the app is also facing issues.
App is giving you the issues. That's what I'm able to listen. Kindly speak a little bit slowly. As your internet is slow, then I will be able to hear, I think.
I'm asking, sir, have you done?
How much?
Questions done
Today.
Yeah.
This is the first question that we are going today. I have just introduced the concept of mean free path. I can show you the earlier slides. Don't worry. Okay. So you can click the picture if you want. This is the definition. Otherwise, also you will be getting the PDF later on. Yes. This is the first slide in which I introduced the concept of mean free path, and this is the formula that we will be using. Okay. This much we have done till now. And this is the first question. Now, what do you think about it? Now, you are having a formula. Very good, Siddesh. Yes, but you might be getting the slides every day also, isn't it? Very good, Rita. Where is from? Students, if anyone knows from where to get the slides, please tell him. Sugat does not know where to get
It's from the website itself. You have to go to our courses, enter login, and then you will receive the slides.
Sugat, now, you know, are you able to hear Arun? Sugat, is it clear or not? Arun just said something about how to download these PDFs.
Yes, sir, I got it. Okay, I got it.
Yeah, you can download all the PDFs.
Oh, sir, I joined that late, so I didn't know that we could do that. I always use the recorded sections.
Okay. So now it will be beneficial for you. You can download all the PDF slides also.
Yes, sir. Okay. Thank you, sir.
Okay, welcome. Yes, Akhilesh is correct. Jayashri, Divya is wrong. Prachi is wrong. Ritika, Jayashri, very good. Yes, Abhay is correct. Yes, Arun. Yeah, Arun, it's wrong. Jayashri, it's correct. Actually, the correct option is B. Now, who will tell me how? Lots of students, they gave the correct answer. Let me
Mean path independent
mean free path. Yes.
did not depend temperature.
Okay. So, is there any other quantity that depends upon temperature according to you in this formula?
No sir, frequency change हो जाएगी ना, तो D option नहीं हो.
But the option B says that the mean free path of the gas molecule will not change when you are increasing the temperature and the average speed is getting doubled. Why?
Path same रहेगा और frequency increase हो जाएगी.
Yes, very good. See, students, question was actually very easy. Okay, but some of the students, they may think that the temperature is increasing, obviously the velocity will increase. Now they will travel that path length more frequently. Means the time taken will reduce. But obviously we cannot change the path length. Na? Path length is not changing at all. It is a distance. Okay, the only thing is now the molecules, they are traveling with greater velocity. Now they are traveling the same distance with a greater speed. Okay, and we have to calculate the average distance. And when the distance it is not changing, the average distance also will remain unchanged. So that's why the B option is there. And D, why D is wrong? It is automatically linked with B. When you are saying that the distance is same, now obviously the velocity will increase because it is directly proportional to temperature. So time taken will reduce, and when the time taken reduces, collisions will occur more frequently. Na? There will be
Yes, sir.
more number of collisions in the same time. Okay, so the collision frequency, it will increase. So that's why D option is wrong. Clear to everyone?
Yes, sir.
So please write down that the time, or should I? Let me write it here. With increase in temperature, with increase in temperature, the velocity, first of all, let me write the velocity of molecules and they will take okay. So correct option is B. Now another one. Two boxes A and B contain an equal number of molecules of the same gas. Equal number of molecules means N is same. Okay, if the volumes are VA and VB and lambda A and lambda B, this one again from IIT Jam 2018. So this is the formula. Now let me give you a hint. This N is the number density. I wrote number density. Yes, number density means number per unit volume. So can I write it as where small n is N by V? Now N is the number of molecules, V is the volume. So N is same, V is different, and lambda is different. And molecules are of the same gas, so diameter is also same. Okay, so N is same, D is same. The only quantity that is different is V. Na? Okay, so it means lambda by V, and this quantity is same for both the gases. It means lambda A by VA should be equal to lambda B by VB. Na?
Okay.
Yes, very good, Divya, Uzma.
Yes sir.
So because N and D are same for boxes A and B, therefore lambda A by VA should be equal to lambda B by VB. Please check everyone. Clear? Easy, na? Very easy question. Done, everyone?
Yes, sir.
Yes, sir.
Another easy question based on mean free path from IIT Gen. Two gases having molecular diameters D1 and D2 and mean free paths are trapped separately in identical containers. Identical containers means now the volume is same. Okay. But now the size is different. Assume there is no change in other thermodynamic parameters. Fill in the blank type from IIT JAM 2019. Yes. Try to solve it. No, Siddesh. Please check again. Now instead of small d, they are giving capital D. Very good, Usma. Very good, Mamta. Very good, Sanju. Very good, Arun, Jashri, Divya, Kapil. Very good. No, Jashri, it's wrong. Yes, Rita. Clearly, it is inversely proportional to d square. Na? So how can it be 2? It's wrong, Abhay. That's it. It's 4:1 because lambda is inversely proportional to d square. So lambda 1 by lambda 2 will be d2 square by d1 square. Please check it. Clear? Is it clear to all?
Sir, how did you know that n for the two gases are same?
Kindly read this.
Okay, sir.
Given na?
Yes, sir.
So now let us study about Maxwell-Boltzmann distribution of molecular velocities. Maxwell-Boltzmann distribution, law of molecular velocities. So Maxwell was the first to point out that molecules, they travel with different velocities. So there are 3 kinds of velocities. And what are their names? 3 kinds of velocities?
Average velocity, mean velocity, and RMS velocity.
Yes. And there is a curve between velocity and the number of molecules. Na? This kind of curve is there. Either you can make PV or NV. Like this, na? Most probable. Then comes average. Then comes VRMS. So this is the ascending order of these velocities. Okay. So of course there are different expressions. You should know all these expressions for 1D, 2D, or 3D. They can ask you about any formula. So let me write the general formula. Okay. So P, V, D, and V. So right now I am writing this formula for n dimensions, so that later on we can generalize it for any dimension, 1D, 2D, 3D. Okay. One D, 2D, 3D. Okay.
So this pressure versus volume graph for yellow.
It is probability. It is not the pressure. I'm coming on to that point. It is the probability of the molecule to have velocity between V and V plus dV. Let me write. PV dV is the probability that speed of lies between V and V plus dV. And this is PV. This is probability. Okay. Now, what is there for 3D, 2D, 1D? Let us discuss in detail now. Okay, so now I will be substituting n is equal to 3. So for 3D, it will become PV d cube V m by 2 pi k t raised to power 3 by 2. Okay, I have replaced m by 3 now. Now d cube V means it is the volume, three-dimensional volume in the velocity space. And if we make use of spherical polar coordinates, you know the volume element is given by r square dr sin theta d theta d phi. So similarly, this will be given by v square sin theta dv d theta d phi. Okay. Or if we take the limits theta varying from 0 to pi phi, the only variable in this expression is v. So then can I write it as 4 pi v square dy? Because when we integrate it over theta and phi, we will end up getting a factor of 4 pi only. We have seen this so many times in electromagnetic theory. Do you remember? This should be from 0 to 2 pi. Do you remember this?
Yes, sir.
Yes, sir. From the spherical coordinates.
Yes, for spherical polar coordinates. Yes. Okay. Clear? It means you can replace this factor by this 4 pi v square dv. And what is the kind of graph that we have? Exactly similar to the earlier one that I made on the previous slide. V. So I will be making this curve for two different temperatures so that we can make a comparison between two. This is for one temperature. This is for another temperature. Now you can see, you can make a comparison between these two. This is for temperature T1. This is at temperature T2. So what do you observe? And this part, it is proportional to V square. And this part is proportional to exponential. Okay. And this is PV. And one more thing. The maxima of this curve, it comes here. P max 1, you can say. P max 1. And the maxima of this one will come here. It is P max 2. So now there are some observable differences between these two curves. It means when we increase the temperature, the whole curve, it shifts towards right hand side. And it gets flattened also. See the difference between this peak and this peak. It is getting flattened and it is shifting towards the right hand side. And because of this, the probability of the molecule to have velocity between V and V plus dV decreases, and the most probable velocity it increases. Okay, and this rise of the curve, it is proportional to a factor V square. This dominates while rising, and while falling, this exponential factor dominates. So rise is you can write rise parabolically, and falls exponentially. Okay, this is very important. This may be asked directly in the exam. That for 3D, rise is parabolically or how it depends upon V. Okay, clear or not? Is it clear?
Yes, sir.
And listen to me carefully. You are not going to get all these things in the books, in any of the book. Okay, so please concentrate. Divya, have you made the graph? Have you made the graph? Divya? Now see, while rising, I said that this part it is proportional to this, and V square means it is parabolic relation. So rise is parabolically, and while coming down, while falling, after the most probable velocity, this exponential factor dominates. It means fall is exponential. Its variation is exponential. And then when you are increasing the temperature, because T2 is greater than T1, what is happening? The curve is shifting towards right. It means the most probable velocity it is increasing, but the number of molecules that have velocity between V and V plus dV it decreases because this peak is coming down. Okay, clear?
Yes, sir. Sir, please explain in Hindi.
Okay. बेटा जब टेम्परेचर इंक्रीज कर रहे हो आप, लो टेम्परेचर पे दिस टर्म डोमिनेट्स. तो राइजिंग के लिए वी आर सेइंग दैट इट इज प्रोपोर्शनल टू v स्क्वायर. तो v स्क्वायर की तरह v स्क्वायर मींस पैराबोला. तो पैराबोला बिहेवियर है. और जब फॉल कर रहा है एट हाई टाइम मतलब हाई वेलोसिटीज पे, तो ये एक्सपोनेंशियल टर्म डोमिनेट करती है. तो जो फॉल है वो एक्सपोनेंशियली वेरी करता है. मतलब ये दो ही टर्म है ना, वेलोसिटी डिपेंडेंट, या ये है या ये है. लो वेलोसिटीज पे v स्क्वायर डोमिनेट करेगी, हाई वेलोसिटीज पे एक्सपोनेंशियल करेगी. और जब आप टेम्परेचर इंक्रीज कर देते हैं, मोस्ट प्रोबेबल वेलोसिटी देखिए मैंने यहां पे रिप्रेजेंट किया, वो इंक्रीज कर रही है. हायर टेम्परेचर पे ज्यादा, और वो आपको पता है क्योंकि इट इज डायरेक्टली प्रोपोर्शनल टू टेम्परेचर. और दूसरा क्या है कि जो प्रोबेबिलिटी है वो कम हो रही है. यहां पे देखिए दोनों की पीक. ओके,
Yes, sir.
and you can define this probability like this also. Can I write it this way? These are the number of molecules having velocity v. These are the total number of molecules. That's how we will get the probability so that the molecule has velocity v. Na? Clear? And if you write PV/dV, it can be written as NV/dV by L. Now this NV/dV will become number of molecules having velocity between v and v plus dv. Okay, clear? It means we can say that with increasing temperature, the number of molecules having the most probable speed, it decreases. Okay.
Yes, sir.
Now there are less number of molecules having most probable speed, but you should keep this thing in mind that now the most probable velocity, it is higher from the earlier velocity, earlier most probable velocity. That was at temperature T1. वो भी तो change होगी ना? Okay? Clear?
That means the velocity, most velocity is increasing, but the number of molecules contribute to the most velocity, it decreases.
Yes. Actually, this area under the curve, it remains constant. Okay? Because the curve is flattening. So it flattens itself in such a manner that even now it occupies the same area as is being occupied by this curve earlier. जितना एरिया इस कर्व के अंदर होगा, this first curve, उतना ही एरिया इस कर्व के अंदर होगा. क्योंकि number of molecules they are constant ना. We cannot change the number of molecules. So total number of molecules they are constant, isn't it? Okay?
Yes, sir.
The only thing is that now there are different number of molecules with different velocity. That is what happening with the change in temperature. Now for 2D, for 2 dimensions, you might not have studied this for 2D earlier, but I will tell you about the 1D case also. That is very much interesting. A strange result is there in 1D case. But now here it will be 2 pi v dv. Just as in 3D, we said that the volume it is a sphere. Na? Actually, in 3D, how we got this volume? Actually, this volume was like this. We made 2 spheres with velocity, with radius v and v plus dv, and this volume was the volume of this spherical shell, isn't it?
Yes, sir.
And similarly, in 2D, now instead of sphere, there will be 2 circles, na? With radius v and v plus dv. Now these are circles, and even now we talk about this area now. And what is this area? This is 2 pi v dv. Na? Please check. Is it clear? It means we are talking about the number of molecules which lie within these 2 circles. Only those molecules, they will have their velocity between v and v plus dv. Na? Clear? Yes, please.
Yes, sir.
And what is there for 1D? Of course, for 1D, we should write it as pvx dvx or pvy dvy or pvz dvz, because the motion is along only one of the particular directions now. So now it will become 1 by 2 now. And also it will include mvx square by 2 kt dvx now. Only dvx now, because it is 1D only. Okay? Clear?
Yes, sir.
So now, first of all, let me make the graph for 2D also. I will be again writing this on the next slide. I forgot to make the graph for 2D. Let me make the graph. Because now the rise and fall, it will be different from the previous case. Na? That's why I need to make this. Have you noticed some difference? Now, I have made these lines to be linear ones. These are straight lines. Na? Again, T1, T2, T2 greater than T1. So this one is proportional to V because of this term. And this one is still proportional to exponential 1. Okay. So rise is linear. Rise is linear. Linear means for small v. Means for v less than most probable. Okay. And fall is exponential. That is for large v. Clear? And then those common things are there, that the probability is decreasing and the number of molecules are decreasing, most probable velocity is increasing, so and so. Okay. But the main thing is this, that how this behaves for small velocities and large velocities. That is very much important. Clear to all? And everything comes from the expression itself. You can see a factor of v raised to power 1 was coming and exponential is there. Clear?
Yes, sir.
Now, for 1D, the expression was this. And for this, the curve is, now it is an important one. This is the temperature T1, this is the T2, so T2 greater than T1. Okay. And this is the only curve which is symmetrical. You can see all other curves, they were non-symmetrical. No? You can write curve is non-symmetrical. They are non-symmetrical around their most probable velocity. Na? This one also. Curve is non-symmetrical. Na? Okay, Dave. Please don't annotate here. What is the need to annotate here? Okay. And here, so why the curve is symmetrical around Vx equal to 0? So now we will have some mathematics about it. Then you will be able to understand. So curve is symmetrical. Okay. I will explain it, why it is so. See, why the maxima is there? Actually, in 1D, the most probable velocity, it is 0. Most probable velocity, it is 0. Let us solve it. Okay. So expression for pvx, it will be m by 2 pi kt. So I have dropped the factor pvx. Okay. So after dropping this factor, I will be able to get pvx because I have plotted this quantity over here. So pvx will be this. So now we want to see the value of the curve at vx equal to 0. So at vx equal to 0, we have. So p0 will be this quantity, m by 2 pi kt square root. You can see. And according to me, I think this is the max value because the exponential factor, it is giving you the value 1, and that is the max value that a decreasing exponential term can give you. Because otherwise, vx square will be positive all the time. M is also positive, kt is also positive. So that exponential will be less than 1. So this is the max value. Okay. So which is the maximum value of pvx. So that's why I have shown maxima at vx equal to 0. So this thing is clear to all now. That there will be a maxima in the curve at vx equal to 0, and the curve will be symmetrical around vx equal to 0 because of this term, because of vx square term. Okay, because this term will behave similarly for positive vx values and negative vx values. So that's why it will be symmetrical for symmetrical around vx equal to 0. Is this thing clear to all? That why it is symmetrical and why vx is for vx equal to 0 it is maximum.
Yes, sir.
Now, what do we have to do to find most probable velocity? Let us also prove that vx equal to 0 is the most probable velocity. Now we know that for maxima or minima, we need to put the derivative equal to 0. So of course, most probable means we are looking for the maxima. So that's why we will put the derivative of pvx with respect to vx equal to 0. So this gives us, of course, this is a constant quantity independent of vx. Exponential will remain exponential. And now we will differentiate the power of this. Minus m into 2vx by 2 kt equal to 0. So clearly, this expression cannot be equal to 0 because this is the original expression that we have. If this becomes equal to 0, then there will be no curve at all. If the probability is 0, then it means the system does not exist. So the only thing can be 0, it is this, and it means vx equal to 0. Obviously, vx most probable equal to 0. It is 0 at vx equal to vx most probable. So replace this vx by vx most probable. Only then this is 0. Is it clear to all?
So can you repeat the last point?
This derivative is 0 only at the most probable velocity. It is non-zero at all other velocities. So after differentiating, when we put vx equal to v most probable, only then it will be 0. And I said this quantity cannot be equal to 0 because this is the same quantity that we are having to start with. Or अगर आपने ये 0 कर दिया, then everything will vanish. Then obviously the curve will not exist. It means the system does not exist. अगर किसी system की probability 0 है, so can that system exist in real life? No.
No, sir. No.
So it means the only thing that can be 0 is this quantity, and this means only most probable is 0. Clear? So now you should remember this result. This is very important. That for 1D, most probable velocity is 0. Clear?
Yes, sir.
Yes, sir.
And what is the way to calculate average velocity? Do you know? We calculate average using this formula. Obviously, if the curve is normalized, this factor will come out to be 1. Okay. Now let us calculate the average velocity for 1D case. So for 1D case, I will write vx. And if I'm using the normalized expression, then there is no need to write the denominator part because pvx dvx integral will be 1. So obviously, I'm using the complete expression. Means m by 2 pi kt. I need to say, some of the students, what they do is they forget about this term. If you are not putting this term into the expression, then the expression, it will be the unnormalized expression. Then you need to have this term in the denominator in order to get the actual result. Okay. But if you are making use of this term or if you are writing the complete formula, then this denominator is not required. Okay. Because then it will come out to be 1. You can check it by solving. वो 1 ही आएगा. So now this factor is independent of v. Now I think everyone knows the value of this integral. What is the value? Very simple. What is the value of this integral? Everyone knows this, I can guarantee. Every one of you know the value.
Sir, root pi upon.
No, not at all. When I'm saying everyone knows, so kindly concentrate. This formula, I don't think so that everyone knows about this formula that you are talking. Limits are symmetrical. This is the hint.
0, sir.
Yes, it is 0.
0.
Because this is an odd function. Limits are symmetric and function is odd. So integral is 0. Why it is odd? Because it is Vx square. So this is an even part, even function. But this is Vx, only Vx. So it is odd function. So odd into even, it will be an odd function. Clear?
Yes, sir.
So it means in 1D case, very strange. Most probable is 0 and average is also 0. So in 1D case, both therefore we consider VRMS only. It means 1D may we will consider only VRMS. That is the meaningful information that we have, because both others are 0, most probable and average. Okay, they fail to give any you can say meaning, because they are not having any value. Okay, and now let us calculate VRMS. Now remember, all the time I keep on saying that VRMS, it means root mean square, and just do the opposite. First square it and then take the mean, then square root. I will be able to get VRMS square, isn't it? And this quantity will be now it is an even function because now it is Vx square. So now you can make use of that formula that you are telling me. So let me write that general formula. You can make use of this formula. So if I make use of this formula, I will get, in our case, A is 2 now. This is called gamma. Do you know about this gamma function?
No, sir, not yet. अभी पढ़ा नहीं gamma function को.
Okay. So this is called gamma function actually. I will tell you the value also. Gamma n is n minus 1 factorial. Okay. This is the value. Gamma n is equal to n minus 1 factorial. So m by 2 pi kt square root.
Sir, slide behind.
Okay, hold on.
Okay, sir.
So 2 kt by m 3 by 2. This will be 3 by 2, and this will be gamma 3 by 2. So m by 2 kt factor will get cancelled. 1 by 2. So I'm left with 2 kt by m factor, and along with that root pi. And this gamma 3 by 2 is half root pi. Okay, gamma 3 by 2 is half root pi. Actually, how it is half root pi, let me tell you. Gamma 3 by 2 is half factorial. Okay, and can I write half factorial as half into half minus half factorial? And minus half factorial is root pi actually. Okay, clear? You write 9 factorial as this, 9 into 8, or you can write 9 into 8 into 7 factorial like this. Same thing I have done. It was half factorial, so it is half into half minus 1 factorial, like that. So now that root pi factor will get cancelled. 2 will get cancelled, so it is kt by m only. But it was VRMS square. So this gives VRMS square as kt by m, because it was mean of the square. So it means VRMS will be square root of kt by m. So this is the expression for the root mean square speed in 1D. In 1D only. Clear?
Yes, sir.
Yes, sir. Add one more, sir.
Yes.
Please write it. Please write it.
Actually, we have solved for the mean of the square. Na? So mean of the square means it is VRMS square, because we have yet to take the square root of this. Na? So ये जो आपने find किया है, this is square of root mean square. Na? So what will be the root mean square value? It will be square root of this quantity that you have calculated.
Yes, sir.
Okay. Clear?
Yes, sir.
Excuse me, sir. Sir, आपने minus 3 factorial को root pi कैसे लिखा?
This you need to remember. Na?
Okay, sir. Sir, any negative number factorial और जिस तरफ मतलब minus half factorial equal to root.
सिर्फ minus half factorial का root pi है, सभी का नहीं होगा. Again, an important result. Earlier we said that average of Vx will be 0, because it was an odd function. But if we take average of mod Vx, now mod Vx is an even function. It means the integral of this one, it will be non-zero. We cannot say that this integral will be 0, isn't it?
It's a meaning of mod V. Yes.
Mod Vx means you are assuming that the particle is moving only in positive, means it is having only positive velocity. It is moving in one direction only. Just as you consider particle in a box and you say that the particle is moving from left to right only. Okay. Velocity is a vector quantity. It means the particles are moving towards one side only. They are not coming to the other side. Mod का मतलब ये है. Okay. That's why the average was 0. Na? So clearly it makes sense when something is going towards right hand side and equal quantity is coming towards left hand side, they both will get cancelled. Na? And the net result will be 0. That's why the average was 0. because there was equal probability of particle going towards right and towards left. But now we have restricted the particle, okay, to go to one side only. So obviously our net result is 0 nahi hoga na? Because there is nothing that is coming backward. Na?
Yes.
So it will be no 0, and otherwise also it is clear from the integral, because this is an even function. Mod is always an even function, and exponential is also even because it contains Vx square. So now we can solve it. Now because it is clear that it is an even function, so can I write it as twice integral from 0 to infinity? Can I?
Yes, sir.
And now we know the value of this integral. Na? Again, you can make use of this formula. But one thing you have to keep in mind, that this is for minus infinity to infinity. It means for 0 to infinity, the value will be half of this. Na? Okay. So don't forget to put a factor of half. And in fact, that half will get cancelled with this 2, like this. Okay. And now the factor will be 2 kt by m power 1 plus 1 by 2, gamma 1 plus 1 by 2, isn't it? Because now the power is 1. Na?
सर हाफ कैसे?
Yes. Any doubt?
सर 2 into 1 by 2 कैसे किया?
2 तो it was already there.
Yes sir, but 1 by
अभी मैंने बताया बेटा, you are not listening to me. It means this is the value for minus infinity to infinity, but you are using this formula for 0 to infinity now, na?
okay sir.
So 0 to infinity के लिए the value will be half, na? So that's why you need to put a factor of half, otherwise you will get the wrong answer. So 2 kt by m power 2 by 2, it means 1. So gamma 1. Gamma 1 means 0 factorial. 0 factorial is 1. So now you can solve it. What is the value? 2 kt upon pi m square root. Na? Please check. Is it clear?
Yes sir.
Let us discuss one question based on 1D results that we have derived from IIT JAM. A gas of molecules Divya, as far as I am concerned, according to me, these are more than enough. According to me, these are more than enough. So you can see that we are covering lots of questions based on a particular topic in the class itself. That Aranka material, it is only for your practice. If you have enough time, then you can go for more practice. But otherwise, according to me, it is more than enough. Because if the concept is not clear after solving so many questions, then it doesn't matter how many questions you are solving, isn't it? Welcome. So that's why that day also one girl was saying that in material the questions are less. That is the reason. Okay, so either we can give you the question in the material, but the best part is we want to discuss each and everything in detail. So that's why we are discussing much of the material in the live class only. Okay, so that is the best thing about Aranka. Because otherwise you might have a lot of problems in understanding the material. Okay, so that's why we are discussing it here in the live class. IIT JAM 2010. So these are 1D component, na? Vx, Vy, Vz. So you can make use of the 1D result. Please note down the question. I will solve it for you. Note it?
Yes sir.
Now, see, we need to solve this quantity. Na? Vx minus alpha Vy, beta Vz square. Mean value. We have to access its mean value. Okay, so let us solve it. It will be Vx square, alpha square Vy square, beta square Vz square, and then minus 2 alpha Vx Vy minus 2 alpha beta Vy Vz plus 2 beta Vx Vz. This na? So now we can separate all the terms. Vx square, alpha square is constant, so Vy square average, beta square is constant, Vz square minus 2 alpha. It is Vx into Vy. 2 alpha beta Vy into Vz. 2 beta Vx Vz. Now all these terms are 0 na? Because we have seen that average value in 1D is 0, and this value was kt by m, na? Vx square. Remember?
Yes sir.
And all other terms are 0. So we can take a factor of kt by m outside, and we are left with. Now a trick is there with me. A trick is there with me for the exam. And what is the trick? Find out the coefficients of Vx, Vy, Vz. Here the coefficient is 1. Here it is minus alpha. Here it is beta. So what you have to do is you have to square them up and add them up and multiply by a factor of kt by m. That is the answer straight away. You can see. And now you can apply this trick on various questions. Okay.
Yes, sir.
Just find the coefficients of vx, vy, vz. This trick is for square only. Okay. When you have to calculate the mean of the square. Okay. Just.
Sir, for 1D only.
Yes.
For 1D only.
Yes, for 1D. Obviously, vx means 1D. Na? When you are talking about one single component, it is always 1D.
Yes, sir.
Okay. Clear? And now see, this A option is correct. Na? Okay. So that's all for today, students. So kindly note about Saturday. Okay. Again, let me tell you, Saturday, no class. But Friday, you will be getting the notification tomorrow. Okay. You will get notification tomorrow morning that there will be a class tomorrow or not.
Thanks for informing me because I have joined late.
Yes. But I'm
Thanks for the information.
Okay.
I have been late.
Welcome. You will be getting the message on your Telegram also. Okay. So please note this, students, because some of you might have joined late now. So that's why I'm informing you again.
Yes, sir.
Okay, students. Bye bye. Take care.
Okay.
Thank you, sir.
Yes, sir.
Thank you, sir.